Hello everyone, welcome back to Chapter 7. This is Part 3. And in Part 3, we're going to take the chemical reaction, the balancing equations, the molar mass, formula weights, and we're going to take that one step further and we're going to predict a limiting reactant. In all of the reactions that we had prior to this, we had all that you needed, okay, except for one thing. So the difference in that and a limiting reactant problem is that it tells you how much you have of each thing. So back to the pizza analogy, we said that you had one crust, 5 ounces of tomato sauce, and 2 cups of cheese, and that would produce one pizza. So oftentimes, if you go into the pantry, if you're like me, you hadn't been to the grocery store as much, you go in there and you kind of do an inventory. You got 4 crusts, 10 cups of cheese, and 15 ounces of tomato sauce. So how many pizzas can I make? Well, I have enough crusts to make 4 pizzas. I have enough cheese to make 5 pizzas. But I only have enough tomato sauce to make 3 pizzas. And so since the smallest number of pizzas I can make, I'm limited by this thing we call the limiting reactant. So I could, if I had enough of everything else, make 4 pizzas with the crusts. I could make 5 pizzas with the cheese, but I only have enough tomato sauce for 3 pizzas. So I can't make more than 3 pizzas. And so that is my limit. Okay, and it's limited by that smallest, it's not always the smallest number. As you see, 15 is a pretty big number, but it's the smallest proportion that I need in making the pizzas. And so this is just a picture of it, so you can kind of visualize it if you need to, and seeing that how that 15 ounces of tomato sauce limits how many I can make. So since the limiting reactant is the amount of tomato sauce in that, it's a limiting reactant. We also could call that a limiting reagent. You might see that. And that's just another word. Basically, a reagent is typically a liquid. So the maximum number of pizzas that can be made depends on whichever ingredient is going to limit us, and that's called the theoretical yield. And the theoretical yield is based on the balanced chemical equation. So in a perfect world, theoretically, that's how many pizzas I could make. That's the maximum pizza I can make based on the limiting reactant. So I can then calculate something called actual yield, and then I can calculate percent yield. So my percent yield, if I can make 2 pizzas, I only get 2 pizzas. I had enough to make 3 pizzas theoretically, but you know me, I'm kind of a bull in a china shop in the kitchen, and I probably spilled some, and so I ended up not having enough for 3 pizzas. So I only made 2 pizzas out of 3 that I theoretically should have made. So 2 pizzas divided by 3 pizzas times 100 would be a 67% yield. So I didn't do too very well, right? Maybe I could have made a half a pizza and that would have made it better. So the limiting reactant or reagent is what is going to be completely consumed in the chemical reaction. And so it limits how much product I can make. The reactant in excess is the one that I have left over after I do this reaction. The theoretical yield is how much product can be made in the chemical reaction based on the limit. And the actual yield is how much I actually produce. And then the percent yield is the actual yield divided by the theoretical yield times 100. So remember, this is from the equation, and this is what we see in the lab usually. Okay, and that gives us the percent yield when we multiply it by 100. Okay, so let's do one. The limiting reactant, so ammonia can be synthesized with this reaction. So we got 2 moles of NO and 5 moles of H2, and we can then make 2 moles of ammonia and 2 moles of water. Okay, you'll know it's a limiting reactant problem when you see 2 things to start with. So it doesn't just tell me I got 86.3 grams of NO, it tells me I've got 86.3 grams of NO and 25.6 grams of H2, and it wants to know the theoretical yield. So what that means is I'm going to look at both of these, see how much ammonia they make, and then that's going to tell me which one is my limit, right? So it'll tell me which one is my limit. Okay, and that's the yield. That's based on this balanced chemical equation. Not on any lab information, but this just tells me what I start with, and I can calculate what I should be able to make. So the difference between this problem and some of the other problems, or the regular stoichiometric problem, I should say, is that you have to run them both. You have to do both of them to see how much ammonia you're going to make, and whichever one makes the smallest amount of ammonia is the one that is going to limit your reaction. So you've got 86.3 grams of NO. Now I need to know some information. I need to know the formula weights of NO, and that one's pretty easy. It's 14 plus 16 is 30 grams per mole. And NH3 is 14 plus 3 equals 17 grams per mole. And of course, H2, if we need it, that's just going to be 1 times 2 equals 2. Okay? So, I've got 86.3 grams of NO. Got to get rid of grams of NO. So this is just like the stoichiometry stuff we were doing in the previous part. And so we said for NO, we've got 30 grams of NO and 1 mole of NO. We're making ammonia, so we're comparing it to ammonia. So moles, I've got 2 moles of NO and 2 moles of NH3. And you're saying, well, I could just say 1 to 1, right? You could, but that just gives you another place where you could make a mistake. So I usually just write it as it's balanced. So then I need to get rid of moles of NH3 because I want to see how many grams of NH3. And so there are 17 grams of NH3 and 1 mole of NH3. And if I did everything correctly, I'm going back and checking, then that should give me grams of NH3 based on the 86.3 grams. And that gives me 48.9 grams of ammonia. So if all it gave me was that, I'd stop and that would be the answer, right? But in this one, it gave me 2 things I'm starting with. So now I have to go back and do the other one. 25.6 grams of H2 times 2 grams of H2 in 1 mole of H2 times the molar ratio is 5 moles of H2 it is compared to 2 moles, right, of NH3. And then this is the same because the molar mass of NH3 is still the same. And that ends up giving me 87.0 grams of NH3. So which one is the theoretical yield? I can't make any more than my limit, right? My limiting reactant. So I can only make the smaller of the two, which means that my NO is my limiting reactant. Okay, so my NO is my limiting reactant, and because my limiting reactant gives me my theoretical yield, which is going to be the smaller one of the two when I compare them. All right, so you have one, and it's similar to that. We're still making ammonia, but in a different process. And so you're going to figure out the theoretical yield, and don't miss the part that these are in kilograms. Okay, so make sure you know that you're using kilograms. All right, and that'll be it for limiting reactants.